Hey, welcome back to your favorite intermediate algebra class. We're going to talk about completing the square today. We're going to solve some quadratic equations by doing so, by completing the square. And we're going to write quadratic functions in vertex form by using the process of completing the square. Okay, so let's look at this first example here. Find the value of c that makes x squared plus 12x plus c a perfect square. So let's take a look at this. Let's think about this for a minute. What would c have to be here to make this into a perfect square? In other words, so it factors into the exact same thing. Exact same thing. So what would c be? Let's say, oh, would it be 16? So would it be 4 and 4 here? Let's see if this works. X squared plus 4x plus 4x plus 16, x squared plus 8x plus 16. You're like, nope, it can't be 16. You could go to something else. Is it 24? Does that work? Or does it, and you keep trying things. But there's actually a trick to finding the c value that makes the process not a guessing game. Okay? So that you can have a perfect square. In other words, two factors that are the same. And so what you do is, let me rewrite this. You take your b term. Okay, so our b is 12. So in completing the square, take your b term, divide it by 2, and square it. Okay, so in this case, our b term, if you notice, is 12. Take that b term, divide it by 2, which is 6. 6 squared is 36. Okay? That's the number that c has to be right here. 36 will make this work. Okay, so let's try it. Let's factor x squared plus 12x plus 36. You notice it factors in two factors of 36. 6 and 6, gotta be positive, positive. And then you check it. X squared plus 6x plus 6x plus 36. X squared plus 12x plus 36. So here's the factorization, right? So c had to be 36 for this to work, okay? And of course, we're going to write the factorization as x plus 6 20 squared, okay? But the question asked me, what does c have to be? Well, c has to be 36. Okay, so you take the b term, take that 12, divide it by 2, and square it. That's what c has to be to make it factor into a perfect square, okay? It ends up being x plus 6 quantity squared when we write that as the square of a binomial. Okay, let's do another one. X squared minus 5x plus c. We want this to factor into two of the same thing, right? So we go to the side, we take the b term, we divide it by 2, and we square it. What's our b term? B is that negative 5. Right, ax squared plus bx plus c. So b is negative 5 divided by 2, square it. Now this is a fraction, so I square the top. Negative 5 squared is 25. Square the bottom. 2 squared is 4. So this c value ends up being 25 fourths. And you're probably looking at this thinking, well, okay, how am I going to factor this thing? Well, the b over 2 is what ends up being right in here. If you're not sure, like if you have a fraction type of deal. Okay, it's always the b over 2. Let's check it. Let's see if it's really x minus 5 halves times x minus 5 halves. Our c was 25 fourths. Okay, so c was 25 fourths. But let's see if this works. X times x, x squared. X times the negative 5 halves x, negative 5 halves x. Negative 5 halves times x, negative 5 halves x. Negative 5 halves times negative 5 halves is a positive 25, multiply numerators, multiply denominators, force. Now, negative 5 halves minus 5 halves, negative 10 halves x, or negative 5x. So there it is, x squared minus 5x plus 25 fourths. So that really did work. Here's our factorization, x minus 5 halves times x minus 5 halves, or x minus 5 halves quantity squared. Our c was also the other part. Our c has to be 25 fourths. Okay. Now we're going to apply that completing the square to solving equations like this. X squared plus 4x plus 1 equals 0. If you notice, if you tried to factor this thing, you go x and x, then you look at the 1, 1, and 1. You go either plus, plus, or minus, minus. You're like, gosh, that doesn't work. That doesn't work. I can't get this to factor out, so I can't just factor it and solve it. So what you do is you factor it by completing the square. Okay, so by completing the square, we're going to solve this thing. Okay, so the first thing we do, step one, is we take the c to the other side, since this thing doesn't factor. Okay, so we just forget about this for a minute. And this is, by the way, as long as your a value is 1. As long as the a value is 1. Okay, if the a value is not 1, you got to force it to be 1. We'll do an example like that in just a second. Okay. So x squared plus 4x equals negative 1. Now, what I want to do with this left-hand side is I want to factor this thing into a perfect square. So go ahead and complete the square with x squared plus 4x, okay? So I take the 4, so I take my b term over 2 and square it. So in this case, it's 4 over 2, b over 2, and I square it, which is 2 squared, or 4, okay? And then, so that's 4. That's what this has to be. I have to have a 4 right here to make this factor into a perfect square, okay? Well, I can't just add in a 4. I'm changing this equation, so I have to add it to the other side. If I add 4 to one side, I got to add 4 to the other side. Use that addition property of equality, okay? So we add 4 both sides. Okay, add that amount to both sides. Now I go ahead and I factor and solve. Okay, so this x squared plus 4x plus 4, that'll factor. X plus 2, x plus 2. Go ahead and you have negative 1 plus 4 over here, so we got 3. Now x plus 2 times x plus 2, you check that by foiling it, right? So you rewrite it as a perfect square. You say, oh good, I got a perfect square, which I've learned if I have a perfect square, I can square root both sides. X plus 2 equals plus minus root 3. Can't reduce root 3, solve for x. X equals negative 2 plus or minus root 3. There's the value of x. Okay, let's do another one. Now you notice this time a is not 1. So I have 2x squared plus 8x plus 12 equals 0. Okay. I'm going to solve by completing square. Okay. Notice I need notice that the a is not equal to 1. Okay, we're gonna have to force that. My a is 2, right? My a is 2. Well, the first thing is I still want to get rid of the 12. Go ahead and take that over. So take c other side. Take c to the other side. Okay. So now I have 2x squared plus 8x equals negative 12. Okay. Now, since a is not 1, I'm going to force a to be 1 by factoring. Okay, so take a 2 out. You notice I can take a 2 out of both the a, the first term here and that second term. So I have x squared plus 4x, and leave a big gap here. I still have this negative 12 over on this side. Okay, you see if you distributed that 2 back, I'd have 2x squared plus 8x, right? Now I'm still completing the square inside that parentheses there. So go ahead and complete the square. Take our b term over 2 and square it. So in this case it's 4, all right? Take that 4 divided by 2, which is 2. 2 squared is 4 again, okay? So we're going to add 4 in the parentheses. Okay, so let's add 4 in. Now, I would usually add 4 to the other side, but think about this. What did I really add? I really added 8 to this side. Okay, so you got to think about that. I really added 8 to the left-hand side. That means I got to add 8 to the right-hand side, okay? Because if you have that 2 in front there that you distribute. Okay, now I go ahead and factor, and solve. Okay, go ahead and factor and solve this thing. So I leave the 2 in front. I factor this x squared plus 4x plus 4, which we already know factors into x plus 2, x plus 2. Over here I got negative 12 plus 8, so a negative 4. Go ahead and write this as x plus 2 quantity squared equals a negative 4. Isolate the perfect square. Should be familiar with this. Oops, divide by a positive 2 there. So I got x plus 2 quantity squared is a negative 2. Go ahead and square root at this point. X plus 2 is plus minus. Of course, this is negative 1 times 2. Square root of negative 1 is I. Got the root 2, can't do anything with that. X plus 2 equals plus minus I root 2. Subtract 2 both sides. That's an I. There. There it is. Negative 2 plus minus I root 2. Okay. So that's what you do if you have something other than a in front. Let's do one more like that. We have this 2x squared minus 24x plus 56 equals 0. Take the c to the other side. Take the b value, divide it by 2. So negative 24 over 2, that's negative 12. Negative 12 squared is 144. Okay. Oh, I'm sorry. Good grief. I'm not even following my own. I'm following my own steps here. Sorry about that. Take a 2 out. I didn't notice my a is not 1. Take a 2 out first. Sorry about that. Okay. All right. Take a 2. Take that 2 out. Now take that b term. Negative 12 over 2. So negative 6 squared, 36. Okay. Add in 36. Now you think about that and you're like, I didn't really add in 36 to this side because I had that 2 in front. I really added 72. So I got to add 72 to this right-hand side, don't I? Okay. Now we factor it. So x minus 6, x minus 6. You notice that's x squared minus 6x minus 6x plus 36. Over here we got 72 minus 56, right? And we got 16. Write this as a perfect square and solve this thing. Square root, x minus 6, plus minus, we square root, that's 4 times 2, so 2 root 2, add 6. And we're done with that, okay? Now the last part of this section we're going to talk about is we want to put a function in vertex form. So if you remember, vertex form is a x minus h quantity squared plus k, where your vertex is that hk. Okay, so we're going to use this completing the square sort of a method here to put this in vertex form. Okay, you notice that this has a perfect square. X minus h quantity squared. It has a perfect square in it. Okay, so we're going to go ahead and push this 7 instead of pushing it to the other side, I don't want to subtract 7 because then I'd have something over here with the y, and I don't want it. I want the y all by itself. So just push that out to the side. Okay. Steps for vertex form here. Okay. Push c out the side. So you got x squared plus 6x and push this out plus 7. And just forget about it for a minute. Now we're just thinking about that right here. That's what I want to complete the square on. Okay, so I go ahead and take my b term, my 6, take that b over 2 and square it. So in this case I got 6 over 2 squared. So 3 squared is 9. Okay, so I add that 9 in. Make sure I really added 9. Now I don't have anything in front, right? I didn't have to worry about it because my a value was 1. Okay, so I did really add 9. Now I'm not going to add 9 over here to the y, okay, because I want y alone. So I'm going to offset it by subtracting 9. Okay, so we add 9 and subtract 9, same side. So I have to offset it, right? Because 9 minus 9 is 0. So I have not done anything to this. Now I go ahead and factor. Okay, factor. So this thing ends up being x plus 3, x plus 3. Of course, 7 minus 9 is a minus 2. Write that as a perfect square. And there it is. There's our vertex form. There's our vertex form. So y equals a, so the a in front is 1, x minus h quantity squared plus k. So my h, my vertex, my h value, this is like x minus a negative 3. So my vertex is negative 3. K is that negative 2. My vertex is negative 3, negative 2. All right, thanks for listening, you guys. Taking notes. Make sure you bring your questions to class.